Can a monopoly with zero actual competitors be forced to charge fair, competitive prices? Our immediate intuition says no. A monopolist can charge whatever they want. But the theory of contestable markets argues otherwise. It suggests that if a market has perfect, cost-free, and reversible entry, new firms can execute a hit and run. They enter when profits are high, take the cash, and leave the moment the original firm tries to fight back. This graph visualizes a natural monopoly facing a specific threat. Let's set the demand function to 1 minus p. We will give our incumbent firm zero variable costs, but a fixed cost of 3/16. That fixed cost creates a constantly decreasing average cost curve. If the incumbent sets a high monopoly price, they invite danger. A new entrant will appear just below that price, steal the entire market, and still turn a profit. To prevent this, the incumbent must slide all the way down their demand curve and set their price exactly equal to their average cost. There are still zero actual competitors in this market, but the mere threat of a hit-and-run entry disciplines the incumbent perfectly. We can translate that price equals average cost rule into algebra. Total revenue is price times quantity, and that must equal our fixed cost of 3/16. When we substitute our demand function for quantity, we get P times 1 minus P equals 3/16. We expand and rearrange the terms, shifting everything to one side of the equation. This gives us a standard quadratic format. P squared minus P plus 3/16 equals 0. Solving the quadratic yields a stable price of 1/4. This is the exact intersection point where the firm covers its costs but leaves zero room for a competitor to undercut them. In a perfect world, maximizing social welfare requires pricing at marginal cost. But here, marginal cost is 0. A price of 0 generates no revenue, making it impossible to pay off the fixed costs. Pricing at average cost represents a second-best welfare state, the lowest possible sustainable price. That model relies on entry being cost-free and reversible. We need to look at what happens when entering a market requires massive, irreversible sunk costs. This flowchart maps the Stackelberg-Spence-Dixit Model. Let's use an inverse demand of 100 minus x. The incumbent's cost is 0, but the entrant faces a sunk fixed cost of 400. Crucially, they move in sequence. The incumbent commits to a capacity first. To win a sequential game, you solve it backward. The incumbent must derive the entrant's reaction function for stage 2. Maximizing the entrant's Coulomb profit against an assumed capacity gives a specific reaction rule. The entrant will always produce exactly half of whatever market space the incumbent leaves open. Because the incumbent moves first, they can perfectly predict how the entrant will respond to any capacity level. That sequence creates a mathematical advantage. Knowing that reaction function, the incumbent has a choice. Pause the video and see if you can calculate the exact incumbent quantity needed to force the entrant's potential profit down to exactly 0. Here is the solution. For deterrence, to make the entrant's profit equal 0, their quantity must drop to 20. Plugging 20 into their reaction function reveals the incumbent must overproduce. They have to build a capacity of 60 units to block the entrant. The alternative is accommodation. The incumbent factors the entrant's reaction directly into their own profit equation and maximizes it. This tells the incumbent to produce a lower capacity of 50 units, intentionally leaving room for the entrant to exist. We run the final numbers to find the optimal strategy. Accommodating yields a profit of 1,250. But blocking entry yields a profit of 2,400. Deliberately overinvesting in capacity is the mathematically superior move. The incumbent weaponizes their sunk costs and massive scale to aggressively close the market. We can test the power of that sequential head start by removing it. If both firms choose their quantities simultaneously in a standard Cournot model, they split the market evenly at 33.33 units each. This calculation shows the outcome. Without the incumbent's early capacity commitment, the entrant's profit is clearly positive. Entry becomes inevitable. This takes time for a new firm to build factories and hire staff. An incumbent can usually slash their prices long before the entrant makes their first sale, meaning hit-and-run tactics rarely work in heavy industry. This matrix summarizes our two frameworks. When sunk costs are 0, The mere threat of entry forces prices down, leaving the incumbent with zero economic profit. But when sunk costs exist and decisions are sequential, the incumbent retains monopoly profits by actively building barriers. Pure contestability offers a theoretical ideal for regulators, but predicting how industrial giants actually behave requires understanding how they use irreversible capacity and their first-mover advantage to protect their territory.